James A.Yorke is a distinguished university professor of mathematics and physics and former chair of the mathematics department at the University of Maryland, College Park. Born in Plainfield, New Jersey, United States, Yorke attended the Pingree School, then located in Hillside, New Jersey. In June 2013, Dr. Yorke retired and stepped down as chair of the University of Maryland's Math Department. Yorke is now a distinguished university professor emeritus with the Institute for Physical Science and Technology Department at the University of Maryland. He and Benoit Mandelbrot were the recipients of the 2003 Japan Prize in Science and Technology. Yorke was selected for his work in chaotic systems. In 2012 he became a Fellow of the American Mathematical Society. Contributions. Period 3 implies chaos. He and his co-author T.Y. Lee coined the mathematical term chaos in a paper they published in 1975 entitled Period 3 implies chaos, in which it was proved that any continuous function f(r) that has a period 3 orbit must have two properties. For each positive integer p, there is a point in R that returns to where it started after p applications of the map and not before. This means there are infinitely many periodic points, different sets of points for each period p. This turned out to be a special case of Sharkovsky's theorem. The second property requires some definitions. A pair of points x and y is called scrambled if, as the map is applied repeatedly to the pair, they get closer together and later move apart and then get closer together and move apart, etc., so that they get arbitrarily close together without staying close together. The analogy is to an egg being scrambled forever, or to typical pairs of atoms behaving in this way. A set S is called a scrambled set if every pair of distinct points in S is scrambled. Scrambling is a kind of mixing. There is an uncountably infinite set S that is scrambled. A map satisfying property 2 is sometimes called chaotic in the sense of Lee and Yorke. Property 2 is often stated succinctly as their article's title phrase, Period 3 implies chaos. The uncountable set of chaotic points may, however, be of measure 0, in which case the map is said to have unobservable non-periodicity or unobservable chaos. OGY control method. He and his colleagues had shown with a numerical example that one can convert a chaotic motion into a periodic one by a proper, time-dependent perturbations of the parameter. This article is considered as one among the classic works in the control theory of chaos, and the control method is known as the OGY method. Books together with Kathleen T. Alligood, Tim D. Sauer and Edward Ott. He was the author of the book Chaos in Dynamical Systems: An Introduction.